Testing. 1, 2, 3. Good afternoon, chat. How is you doing today? Is you doing good? Is you doing bad? All of the ises. Well, I suppose we might as well get started. This is an exam review session. Doing good. We get to go on my weekly grocery run today. Okay. Good. If you can keep it to weekly grocery runs, that's good. So, this is an exam review session. So, do you have any questions about any of the content in the course, or the exam, or anything like that? This is going to be a student-directed session. So, let me poll the audience now. Is there anything you want to know? Can I go over SQL/databases? Why, yes, I can. Aside from constructing SQL queries, how much about SQL do we need to know? Precious little. Yeah, so... Yeah, okay. We can go over it. I think I put my SQL stuff in here somewhat, prior to perhaps its usefulness. Going in there. Whoop, there we go. So, SQLite 3. Wonderful. So, no, I consider the primary useful thing that you should know about. Well, there are three main areas with respect to SQL and using it. You should know how to create stuff and add entries. You should know how to delete stuff and remove entries. And you should know how to select stuff and show entries. You should also know some of the, high-level abstract details, like the manner in which an SQL database is organized into tables, the fact that tables are different things and you have to reference them differently. So if we open up a new database file, say open videogames.db, right? And I'm probably going to have to refer to the notes here. But the other thing is the exam is open. It's a take-home exam, which means it's implicitly open book, right? So with respect to the SQL query stuff, you will have the lecture notes for this course minimally at your disposal, which means that it should, as long as you have the, mental framework for, as long as you're not learning what an SQL database is during the exam, you should be able to just look up the commands for syntax if you're missing them, if you're missing syntax on them, right? So anyway, so let's create table Mario Herm. Oh yes, I need to include the schema. So it will have a game ID, which is a integer. It will have a game title, which is text. It will have a year of release, which was an integer. And that'll probably be good. There we go. So select star from Mario. Oh, geez, that just kills it completely. So I will address graphing and the visualization component once we have dealt with the current databases related stuff. Okay. So .open videogames.db, right? ls, that's not a command. Jeez. So select star from Mario. There we go. No such table. Uh-oh. But I thought we made one. Well, anyway. So if you go into the content, we've got, I think it's in week, this one, databases. Yes. Is it possible? Unfortunately, it's not possible for me to zoom in on the SQLite stuff. Sorry, it's just the command line interface, but sorry about that. There's nothing I can do about it. I could use magnifier, I suppose, but it has been unreliable in the past. So, all right. So, if we want to make an SQL database, we have to create the table in the following manner. So if we pull up our interface here, create table Mario with the schema, we'll just have name, text, and year integer. There we go. So if we select star from Mario, there's nothing in it, but we also don't get the error that there's no table initialized. When creating the schema, do the types for each field need to be capitalized? Well, I think so. Maybe, maybe not. Does it work if we try it a different way? I wonder. Does it have to be? Seems to work. Okay. And then if we insert into Zelda values link to the past, which I don't know, 1994, something like that. And then yep, it works without capitalization. There you go. It works without capitalization. So the things so that's it. You need to know creating a table. You need to know what a schema is, which is all very simple stuff because basically all it is it's like defining the arguments to a function in Python, except you actually have to explicitly say what your data types are. And in most programming languages, you will have to say explicitly what the types of your arguments to any function are. So it's relatively simple. You should be able to select different fields from a database, right? You should be able to specify something where name is equal to Zelda, sure, or where name is, what is it, like? Something like this, I think. There's specific syntax for that, the fuzzy searching. Where a name like, oh yeah, because it doesn't actually the link to the past doesn't actually contain the term Zelda. There you go. Gotcha. So that type of thing, the fuzzy searching is a thing to know, and the ordering by is a thing to know. But once again, this is the type of thing that it's relatively easy to look up in the slides. You just need to, have a sufficient mental framework built in for it to be able to know where the stuff you're looking for is. That's the main thing with this stuff. So, yes. When creating, I already answered that question. So, if that is a sufficient review, if there's anything else anybody wants to see about SQL, please let me know. Otherwise, we'll move on to graphing, and that'll be that. So, with respect to the unit on visualization, right here, the stuff that's necessary to know is you should be able to do a basic plot, right? So, given some x values and some y values, you should be able to import pyplot and create a plot of those values. Okay, so I have a question. Can I explain what fuzzy searching is? I will get back to the. I'll get back to this once I talk about fuzzy searching. So first of all, the big difference. That's the same magnification. Can I increase the magnification? There we go. So with respect to fuzzy matching, it's the same type of matching that you have when you're dealing with stuff inside of your file system, right? So in Linux or in, I don't know, probably PowerShell or DOS does the same sort of thing. If you want to select multiple files, you use an asterisk character in place of some part of the string, right? So if you wanted all of the .png files, you would do star.png, right? The star is the wildcard character that stands for any number of strings. Basically, we're saying we want any number of strings, we just want this to be at the end of it, .png. The fuzzy matching in SQL operates along the same manner, it just uses a different character. It uses the %sign character, which is enclosed inside of the string itself. So you're saying, in the case of link, we want the term link to be in there somewhere with some unspecified string before it and some unspecified string after it. So these can also be empty. So as with this example, if it's the first term, then this will still catch it. So it's a way of expressing a, I want this string to contain this letter or contain this sequence of characters rather than being exactly this sequence of characters. Like otherwise, if you don't use fuzzy matching, you have to, type it out manually. And the other thing that this allows you to do is it allows you to, for example, find all of the Zelda games that have the term or the name Link in the title, which is a subset of the Zelda games. So, hopefully that explains fuzzy matching. So, hola, this is an exam rules review for C01 as it says because usually we don't have a class scheduled. Oh, shoot. Oops, nope, that's me, I'm sorry. I got myself confused. No, this is actually C2. Sorry about that, folks. Yeah, this is C2. Let me just fixture up that right there. Ta-da! There we go. I don't know if that'll take effect right now, but there you go. Will you be posting exam practice review questions? If I have some time, yes. Yeah. I'll dig around and see if I can't dig up some practice questions for you guys. To be honest with you, a lot of the questions that I had from last summer's exam that I would have made exam review questions, I actually made into tutorials instead. So if you review the tutorial material, that would be excellent exam review. Yep, no problem. I mean, we're still going to be talking about interesting and pertinent stuff too. This stuff is interesting and pertinent to both classes, I would think. But yes, so a lot of the things I would have made exam review questions ended up becoming tutorial questions. So in some sense, going back over some of the tutorial material would also be an extremely useful use of your time. But yeah, I'll see if I can't put together a set of practice problems reasonably early in the week. But yeah, okay. So anyway, back to graphing. So you should know how to make a plot. You should... Let's see. Knowing how to plot a function would be nice. Knowing the different types of plots would be good. So knowing the difference between a normal pie plot, a scatter plot, a bar graph, and I think the other one is a pie chart, that would be useful. Oh, and histograms. So just know, again, this is really quite in the category as the SQL stuff. You should have a mental framework built for it that you can plug various things into. And that way, when you need to look up, oh gosh, how do you do this again? I forgot pie charts. What's the command for that again? You can just say, oh yeah, that was at the end of the slides. And it's just .py. That's easy. So yeah, know the different types of charts, know how to make a chart, know how to plug data into a chart. Okay? Cool. Are there any other questions about any of the material? Or anything else? Any philosophical questions? How much should we know from the topic 10.33, dates? Well, it's a good question. It's a rather short topic, this one. So, I am not going to expect you to memorize this this image here. That's not what we're about. So, importing and creating a date-time object is good. Knowing how to get the current time, that's something that you should probably know. Being able to get differences between times, that would be useful, possibly. But I don't think we'll bother with this format conversion type stuff, really. Just be able to work with dates numerically, I think. All of this stuff with respect to formatting, I think that's useful information, but perhaps not useful to study, if we can put it that way. Philosophical question. What is your favorite video game? Mother 3. Although I can't admit to it because it's never been released in North America. But yeah, I'm a fan of the Mother series. Should we know stuff about how to deal with floating point numbers, like using the decimal library, etc.? Yes. that would be a good thing to know. How many marks is the exam out of? Is it 60 like the test, or 100? I don't know. I haven't set the final tally on what everything's worth yet. You can certainly expect it to be worth more than the sort of normal 20 marks that an assignment is usually worth. See, it's interesting because like when I was doing school, you know, back when I had to fight brontosauruses for OSAP money, I always loved seeing a test that was out of a lot of marks, because that meant that any particular mistake that you made had a lesser impact on the overall number of marks. Although I suppose in this particular case there were certain exceptions to that. But anyway, how much should you know about machine learning? Machine learning isn't really going to be on the exam. It's more of an FYI topic, machine learning. It's very interesting and useful stuff to know, but I'm not going to expect you guys. I suppose hypothetically I could whip up like a linear regression question or something like that, but no, machine learning isn't going to be on the exam. So, can I go through a recursion problem? Do you have a recursion problem? Yeah, I can go over like the general procedure for recursion. That's no problem. So, let's say, well, I do kind of need a problem though. Pardon me. Let's do quicksort. It's a good example. So, if we want to define a recursive algorithm, this will take L, which is a list. There are two things that if we wanted to continue studying Python and SQL in our spare time over the summer, what are the next topics we should study? What should we know to be an expert at Python/SQL? So generally speaking, if you're participating, midterm 2 was quicksort, so I'll go over quicksort. Yeah. With respect to where to go from here with respect to studying, generally speaking, I always think that one of the highest value activities you can do with respect to learning a language is to take on a project in that language and follow it through to as close to a conclusion as you can come up with. So, with respect to like next topics, it's real like once you have the fundamentals down, which hopefully if you're doing well in this course, then you should have a pretty good grasp of the fundamentals of Python, possibly also SQL. I like pick something that you'd like to do, a program that you'd like to write, and then do it. I often think that good like programs to learn on are video games. So take some small video game from the ancient times, like, you know, Pac-Man or something, and do a version of Pac-Man in Python. Call it Pyman, something like that. The amount of stuff that you'll learn from taking on a medium-sized project, you know, just taking on a project, that's going to be where you learn the really practical stuff. Like, how do I organize a project in such a way as to not screw myself over, you know, 3 weeks from now? How do I, like, you'll learn what you need to know to be you know, an effective programmer. With respect to like this sort of academic way of, here's a topic, learn that, here's a topic, learn that. That's not going, like, the further you get on, the less that's going to be useful, I think. But that's just, my own personal impression. Experience makes you an expert in Python, not having studied a bunch of books. That being said, there are a number of good Python books. Basically, if you pick up any type Python book, there'll be stuff in it that you can learn that's sort of on top of what we learned today, in this course. The other thing, well, in some senses, you're also kind of just, you need to learn stuff about programming in general, not just learning about Python. Like, if you take a good algorithms course, then the information that you will learn in an algorithms course is applicable to all of the programming that you'll do, not just in Python, but in everything else as well. But yeah, and SQL is a little more tricky. It's difficult to come up with a good self-directed database project that you can get enthusiastic about, because databases in general are kind of dry and not very interesting to work with unless you're a person who sees a lot of data. And if you're that type of person, then you're probably already employed doing something with SQL or large databases or something like that. So that being said, I don't know, any number of things. But yeah, next topics though. Yeah, it would definitely be the algorithm stuff. I would say pick up some graph theory, start learning about data structures, start learning about sorting algorithms and hash tables and linked lists. And you remember that tutorial we did on binary search trees? That's a good example of the more algorithm-centric material. Learn what a matroid is. Learn what a greedy algorithm is. There's a certain amount of that stuff in the course notes as well, but at a certain point. And the other thing is, you might also want to consider learning languages other than Python. Python is good, but it'll hit its limit sooner or later. Python's good for small to medium-sized programs, but you do hit a limit with it after a while. But yeah. Anyway, hopefully that's a answer to your question. So anyway, quicksort. So when you're designing a recursive algorithm, you need two things primarily. You need the recursive step and you need the base case. So in this particular, let's remind ourselves what the quicksort algorithm is all about, right? So you have a list. The quicksort algorithm takes the head element, the first element of that list, and calls it a pivot. It then takes that list and divides it into two sublists. One is all of the elements that are greater than, or this one would be, all of the elements greater than the pivot. And the other one is all of the elements that are less than or equal to the pivot. Then you concatenate these two lists with the pivot in between, but only after having recursively called quicksort on these two sublists that you've generated. So let's see what that looks like. So the base case here is if we have a situation where the length of L is equal to 1, or the length of L is equal to 0, then we just return L. You're welcome. Yeah, there's even if the thing you're thinking about is employment prospects, honestly, having a good portfolio project with respect to programming is like worth like 3 courses. And that's a false numerical equivalency, but it's like having something tangible to show. It's so important. Like, I don't think I've actually ever gotten a job writing code where I haven't shown them some portfolio project and then they've been impressed by it, to be honest with you. But that's just my experience. So that's our base case. When the length of this list is either 1 or 0, we return just the list, because obviously, if the list only contains one element or contains no elements at all, it is by definition already sorted. So, otherwise, we call our pivot L0. Then, just to make this a little fancier, I'm going to define some other functions to help here. So less than list, less than or equal to list, will be equal to filter L0 and define filter. This will take a list and it will take a function for element in list. We'll append this all to an out array. If f at e out dot append e return out. So I have created this filter function, which accepts a function as an argument, applies that to the element, each element in L, and if it comes out true, it appends that. So let's do lambda. Is it lowercase lambda? Yeah. So lambda x in x is less than or equal to the pivot. And then greater than list is, let's make those capitals, is the same thing, but we want it to be greater than the pivot. We then return a big ol' thing. We want to quick sort the less than or equal to list plus the pivot, which is, and it's not plus, sorry, it's concatenation. Quick sort greater than list. There we go. Ta-da! Does it compile? No, I've got a syntax error because, silly me, I am using the double bar notation instead of Python syntax for OR because I'm a big dummy. Incidentally, literally every single programming language other than Python writes the Boolean OR operation like that. So, Okay, thank you for your next question. Let me just finish this one up. So, if we quick sort something like that, we get a type error. Oh, frick, yes. So, sorry. That should be from 1 to the end of the list, not just the element at 0. That makes a lot more sense. And I should be consistent in the naming of my stuff. There you go. Perfect. First try. Just kidding. So, how do you apply something to a function or a dictionary or a list? Let's say you are given a way to sort a list and a list. How do you go about applying that way of sorting it, a list to the list? Or even applying strategy question from A10, how do you apply that strategy? Well, by calling the function, it depends. So if you're talking about, like, there are various ways to work with data structures, right? So in this particular case, in the case of the quicksort function, we have written this algorithm which is applied to a list, right? The function applies to a list that's given to it. This is why in this particular case, it takes that data structure as an argument. Therefore, the manner in which we use it is we pass a data structure into the function. We call the function over the data structure, and that causes that to execute, right? So with respect to the stuff inside of a data structure, the easiest way to apply something to everything that's inside of a data structure is to use a for loop, right? And then have whatever the thing inside the for loop, if you need to, like, for example, and this is, I guess, a relatively trivial example, and I'm not sure that this is actually what you're asking, but here we go. So for E in L, E plus equals 3, right? Return L, I guess. Or that won't even be necessary, but let's do it anyway. So if we add 3 and just, take this. Right. So let me just alias this real quick. Is this not? What am I doing wrong here? For E in L, E plus equals 3, return L. Like, isn't modifying it at all? That's so weird. How is this not working? Okay. So I managed to get something to work. So I'm not sure exactly why it was not working like that, but if you create a new list within that function and then create, like, and this kind of breaks the reference to the old list, right? So I have essentially created a new list out of the modified values of the old list, right? And that works. I'm not precisely sure why it didn't work the other way. Oh, maybe E is like literally the thing. So maybe what I want to do is for I in range length of L, right? Maybe this is it. Maybe I have to explicitly use something like this. Yeah, there we go. That works. Yes, thank you, Chloe. Yes, I just got it. So, yes, I think that when you do this, what you do, like this, the E that I was attempting to assign to is actually not, it's no longer the element of L. Like, it's no longer like just a reference to the address that L's in. What it is it's the actual, it like produces a literal, like a concrete value of whatever it is in L. So if you want to make modifications on the data structure L, then for I in range length L is what you want to go for, rather than just for E in L and then assign to E. That won't get you what you want. Good question, though. So, cool. I think hopefully that answers your question, LMAO. Lamau. Are there any other questions? Well, I think if that's it, then good exam review session, everybody. We'll be having another. I don't know if I'm going to get more questions tomorrow, but I'll show up for the normal live stream tomorrow anyway. If anybody thinks of any more questions, but otherwise, I think this has been a good exam review session. Thank you very much, everybody, for tuning in. And I think I'll end it a few minutes early if that's okay with you guys. But yeah, anyway, cool.